getting to the conclusion of the AdaBoost. Now, AdaBoost searches for a small number of good classifiers rather than considering a large number of classifiers, which may in turn be of no use to the AdaBoost. AdaBoost adaptively constructs a final strong classifier taking into account the failures of each one of the chosen weak classifiers based on the weight. As we had discussed earlier, each weak classifier has an associated weight which helps us determine the importance of each weak classifier, which in turn helps us determine the usability and consideration of the classifier. An AdaBoost is used to select both a small set of features and train the final strong classifier, which is obtained by applying the summation over all the products of the weak classifiers and their weights. Moving on to the third solution to the issues of the Violagens algorithm, the cascade classifiers. Now, certain facts about the cascade classifiers are: equal computation time is spent on all sub-windows. On average, only 0.01% of all sub-windows are positive, which are faces. Then it must spend most of its time only on potentially positive sub-windows. Now we see that in about 10,000 sub-windows, there might be only one sub-window which is positive, which includes a face. A simple two-feature classifier can achieve almost 100% detection rate, which is extremely high, and a 50% false positive rate. As the name suggests, a cascade classifier is a cascade of multiple layers where each layer acts as a kind of a filter. The classifier can act as a first layer of a series to filter out most negative windows. The second layer with 10 features can tackle harder negative windows which survived the first layer, which means that any negative windows which pass through the first layer are then tackled by the second layer, and so on.